You are currently the only person in this conference.
Okay, hello again. Are you listening? Okay, today we have the smaller lecture because I am the night shift now. We're talking about today. I will send you the one anesthesiology Oxford handbook for the anesthesia and one ICU book. Also, I sent you in your mail third and fourth lecture of the anesthesiology in intensive care. Today we are talking about anesthetic equipment in the operation room and the ICU and about oxygen. Next week we have the presentation about the regional anesthesia and local regional anesthetics. After that, it's coming. I think that is the Easter holiday. Uh, and maybe after that, we can start with the ICU presentation about the acid base, about hyponatremia and the problem and therapy in the intensive care unit. Okay, about anesthetics equipment. What is the important? Anesthesiologists spend more time in the operation rooms than any other groups in the physician and are responsible for protection patients and operation room personnel from a multitude of the dangers during the surgery. The anesthesiologist may be responsible for ensuring proper functioning of the operation room's medical gases, fire, prevention and management, environmental factors for temperature, ventilation and noise, and electrical safety. The role of the anesthesiologist also may include the coordination of or assistance with light and design of surgical suites, including workflow enhancements. Patients often think of the operation room as a safe place where the care given is centered around protecting the patient. About the medical gas systems, the medical gases commonly used in the operation room from an anesthesiologist is oxygen, nitrous oxide, air, and nitrogen. We are talking here for the gas system, not for the uh, yeah, desfluran, sevofluran for the anesthetics gas. This is the difference because when we are working with anesthetic gas, we are working with the vaporizer, who is the special, is not the gas system, it's the same. And about the oxygen, a reliable cycle of the oxygen critical equipment in any surgical area. Medical grade oxygen, 99% or 95% pure, is manufactured by fractional distillation of the liquid air. Oxygen is stored as a compressed gas at the room temperature or refrigerated as a liquid. Here you see in the picture one oxygen hospital cylinders. Most small hospitals store oxygen in the two separated banks of high pressure cylinders, each cylinders connected by the manifold. A liquid oxygen storage system is more economical, and yes, in our hospital we are working with the liquid oxygen storage system, who is the special, is out of the hospital in the special place in the hospital, and is the same with the nutrioxide. And yes, the largest hospital, Tokuda, military hospital, Sofia Med, our hospital, we are working with the liquid oxygen storage system with the special area where is the oxygen and nutrioxide. And the liquid oxygen must be stored well below its critical temperature of minus 119 degrees because gases can be liquefied by pressure only if stored below their critical temperature. To guard against a hospital gas system failure, the anesthesiologist must always have an emergency e-cylinders filled with oxygen available during anesthesia. Most anesthesia machines accommodated e-cylinder of oxygen, and oxygen cylinder pressure should be monitored before use and periodically during the use. This is very important. If we have the fire with oxygen, we have the very big explosion and the hospital is stop working. About the nucleoxide, is manufactured by heating ammonium nitrate thermal decompression. Uh, it is almost always stored in special large big H cylinders. Why in the different cylinders? Because the critical temperature of nitroxide is 36.5 temperature is above room temperature. It can be kept liquefied without an elaborate refrigeration system. If the liquefied nitroxide rises above its critical temperature, it will revert to its gaseous phases. And about the medical air, we in our hospital we're working with the oxygen and medical air. About the general anesthesia patient, the use of air is becoming more frequent in anesthesiology as the popularity of nitroxide and unnecessarily high concentration of oxygen has declined. Cylinder air is medical grade and is obtained by bleeding oxygen and nitrogen. The critical temperature of the air is 140 degrees of the, and here is the difference between the characteristics of the medical gas. You can see about the capacity of the cylinders of the oxygen and the air is the same. Difference is about the nucleoxide. Is the difference about the color in the United States and international. Color is white about the oxygen. Is the green in the United States of America. When you have and you can see the cylinder who is blue is for the nucleoxide. If it's the white is for the gases for the oxygen. You can see in the anesthesiologist apparatus in the operation rooms we have special color for the oxygen and for the another gases medical for the anesthesia. About the vacuum, central hospital vacuum system usually consists of independent suction pumps, each capable of handling peak requirements. Traps at every user location prevent contamination of the system with foreign matters. A dedicated vast anesthetic gas disposal vacuum system is generally required with modern anesthesia machine. The vac outlet may incorporate the use of suction regulator with a float indicator. The float should be maintained between the designed markings. Excess suction may result in inadequate patient ventilation, and insufficient suction levels might result in the failure to evaluate the last anesthetic gas disposal. About the recipients and tubing are usually lavender in the color of the vacuum. This is for today. So sorry, we have a very little lecture for today because I'm night shift. I will send you today. I send you about the operation room, about the anesthesia materials. For the next week, do you be here in Bulgaria, or you're going to your country, or after that you are going? Maybe just a second to see. No, maybe next week you will be here. Just a second. Yes. When you come back from before and after Easter holiday.
I found this on the web.
Also, really, probably yes, I know. Okay, but we must. Yes, about this is very important for me to have the lecture online. Next, I think that in the 39 maybe again. I chill just second to see my graphic. Working period. Yes, it is possible to make online lecture maybe in another day if you have some free time. For example, I don't know, because in the 14 next week, I have the lecture with the Bulgarian students in the aula of the hospital. Sure, no problem. Okay, if you like, I will make the in the e-learn, I will make the lecture conference hold and session, and we can see here, you can see the date for the next lecture about anesthesia, because I would like to talk about malignant hyperthermia, which is very important for me and for you to know. I would like to talking about the local regional anesthesia, about the inhaled anesthetics, and I will send you mail, and we are talking when to have the lecture, okay? Because after that is coming the exam. Okay, thank you for everything. See you next week. This Friday at the afternoon, do you have some lecture? Yes. Okay. At 6 we finished. Eh, Okay, I will send you mail. Maybe this Friday we have some lecture, if it's possible for you, for 1 hour to 7. After that, you're going to the party in the student city, maybe. Or another is next week. I will send you the lecture program and see you again. Okay. Have a nice work, not evening. Thank you. Bye bye.
You are currently the only person in this conference.